What if I'm given a spring and I want to find out what the stiffness of the spring is? So how might I do that? Well, let's imagine I take this spring and I attach a mass to it. Okay, so we know that this spring is going to be stretched by some distance x0. And let's say I know what the mass is. Well, then I can also measure what x0 is. I can measure how far it's been stretched. And so then if I do this, I can look at the forces on it, and I know that we have gravity going down. I know that we have the spring force going up, which is equal to k times x0, because x0 is the distance that it's been stretched. And so I can say that F net is equal to 0 minus mg plus 0 kx0 equals 0. So mg is equal to k times x0. So in other words, k is the gravitational force divided by the amount that it's been stretched. So this means that now I can take now that I can take this spring and I can attach anything else to it, and I can calculate anything else that I want, because now I've found what the spring coefficient k is. Right? So now, I can come back and I can stretch this even more. I can pull it down. So now I've stretched some distance d. And recall that we said the energy of the spring is 1/2 k. In this case, it's going to be x minus x0 squared, which is just 1/2 k d squared, because now I'm calling x basically this distance. And so d is going to be x minus x0. And so this also tells us the spring force is minus k x minus x0, or minus kd. And again, so we said that d is going to be x minus x0. So, so just by using force equations like we've been doing, for several units now, we see that we can easily find out, we now have a way to actually find out what the spring constant is for any spring that we want.